So this is the second video on the quadratics chapter, and we're looking at the formula and completing the square. So it's actually the end of section 2.1 and section 2.2. Now I'm going to do this sort of backwards according to the book. We're going to look at completing the square first and then come back to the formula. So completing the square. Now there are various ways of thinking about this, and my advice is to think of completing the square and just to pick an example from the exercise. Completing the square is something you can do to an expression that looks like this. You need the x squared term and the x term. The coefficient of the x squared term needs to be 1. If you don't have that, you can't use completing the square. By the way, I should say that this is the way I like to think about it. There is actually formulas in the book that allow you to think about it a different way, but this is the way I find most reliable and the least confusing. So the formula is that if you have something of this form, x squared plus bx, then you can rewrite it as x plus b over 2 all squared minus b over 2 squared. Okay? Now, I'll point out a couple of things. This isn't strictly speaking a formula, because it's a way of rearranging this expression and rewriting it as another expression. With a formula, you need a subject to the formula, don't you? But it may as well be a formula, right? We're thinking of it as a formula. Secondly, this part here is b over 2, square it, and then put a minus sign in front. So the number at the end is always a negative, okay? Let's just apply that formula then. X squared plus 4x, well, my b is a 4, okay? That b there is a 4 here. So b over 2 is 2, and b over 2 is 2, square it is 4. Oops, I forgot the square. So that expression there is exactly the same as this expression here. Let's just do another example with a minus sign in, just to make it clear. That b is minus 16. So x plus minus 16 over 2, so minus 8. Then I do minus 16 divided by 2, which is 8. Then I square it, which is 64. Then I put the minus sign in front. Okay, so half it, then square it, then put the minus sign in front. And obviously I can just make that a little bit neater in the brackets, like that. Okay, so that expression there can be replaced with this expression here. Now the problem we have then is, what about when we have, with my method, I think it keeps it simple, but it creates a problem for us when we have something like this. And again, I'm taking an example from the exercise here. Oh, I'm going to take a harder example. 3x squared plus 2x minus 1. Okay, and I want to complete the square on this expression. Now I've said that if we're going to complete the square, we're going to need an expression that looks like this. It needs to be an x squared term, an x term, and the coefficient of the x squared term needs to be 1. And I haven't got that. I've got 3 terms here, and the coefficient of the x squared isn't a 1. Well, I can deal with that. If I factorise the 3 out, this is what I sort of sometimes call forcibly factorising it, because the coefficient of x squared isn't a 1. If I take a 3 out, then I can't neatly factorise this. I end up with 2/3 there, minus 1, okay? Sorry, I should have done that in black, because then I'm going to start ringing things in red. So what I've got now is that in this bracket here, I've got an expression that I want, okay? So the thing inside the bracket, I can use the formula on it. Everything else, I can just ignore for the minute. So let's just put the rest of it, 3 and the minus 1. The thing inside the brackets I can replace, okay? Because the thing inside the brackets looks like I want it to look. It looks like x squared plus bx. So b in this case is 2/3, and you might find it helpful to do this, right? B is 2/3. b over 2 is 2 over 6, and b over 2 all squared is 2 over 6 and then square it, so 4 over 36, which cancels down to 2/18, which cancels down to 1/9. Okay? So, this red thing in the brackets can be replaced with x plus b over 2. Oh, sorry, of course 2 over 6 is 1/3. What am I doing? X plus 1/3 all squared. take away 1/9. Okay? So if you've done this little bit of working out in the corner, that thing goes there, that thing goes there, that's always a minus sign. That can be a positive or negative depending on whether this thing here is a positive or negative. Okay, so I've changed that bit inside the brackets to this bit here, and that is the completing the square process, swapping this one for this one. From then, I've just got to simplify what I've got. So that is 3, and remember, we've done all this so that we can get the x plus something in brackets all squared. So don't get rid of that, okay? So when we expand it out, 3x plus 1/3 squared, 3 times minus 1/9 is minus 1/3, and then we've got a minus 1 at the end of the brackets. So 3 brackets x plus 1/3 squared minus 1 1/3. So let's write that as 4/3. And there is my completed square form, okay? You also need to be familiar with sort of spotting completed square form. So completed square form, the important bit is that you have an x plus something in brackets all squared. You can times it by something and you can add or take away something at the end. But if you've got something that looks like that, then you've got completed square form. The thing that, one of the things here that confuses people is when you get to the exam and it says, here we go, there's one in example 9 on page 25. Here's a function, which is a quadratic. Write it in the form x plus p squared plus q, and they think, well, how do I do that? And if you look at that, you need to spot, oh, that's just completed square form. I write it in completed square form. That's what they're asking me to do. So there's completing the square. Now, you'll notice in the book, there's a formula for if you've got ax squared plus bx plus c, and you can just follow this formula. Now, my advice is not to follow that formula. My advice is just to stick with the, well, sorry, again, not quite a formula, it's an identity, strictly speaking, but there we go. My advice is to stick with the easier version of it, which is this one here, which we've dealt with. This one, I think you're more likely to get the negatives in the wrong place and forget there's a 2 here and a 4 here, and you're not sort of thinking about what's going on. So I think you're better off with this and ignoring that. Other people will give you different advice, and obviously, you know, this wouldn't be in a textbook if it wasn't sensible advice on some level. My preference is to stick with these ones. So there's completing the square. Now, completing the square does a few different things for us. One thing it will do is if you have a quadratic that will not factorise, you can use the completed square form to solve the quadratic. So we've said before that if you've got ax squared plus bx plus c and we put that equal to 0, if you try and just use the balance method on both sides, you're not going to get a solution here. If you have a quadratic that's in this form, let's say, I'll use capital letters so they're different a's, b's and c's to here, right? So if we've got a, x plus something else squared, let's say minus something equals 0. If I've got something that looks like that, I can solve it with the balance method because I can add c on both sides. And I would get this. I can divide by a on both sides. And I can square root. And I can take away b. Okay? So with the completed square form, it will allow us to solve any quadratic, even if we can't factorise it. And that's actually what we do to get the formula. Now, you may have seen this before. If you haven't, I'm going to go through it here. If you have no interest, then I suppose fair enough. Hopefully you do have a bit of interest in where things come from, being an A-level maths student. But if I start with ax squared plus bx plus c, and I just try to complete the square, what I'll end up with is the quadratic formula, and that's where the formula comes from. I don't think there's much more to say about the formula. A, b and c are the coefficients of x squared, x and c. You take them and you put them into the formula, and you'll get a solution to the quadratic. Where it comes from, though, is the completing the square method. If you've seen the derivation of the quadratic formula before, that really is the end of this video. That's all I'm going to do, and I'll continue in the next video with section 2.3. If you've never seen this derivation, it's worth seeing once. So, if I was going to complete the square on this, what I would first do is my sort of forcible factorisation. I would then complete the square by changing what it's got in the brackets. my b is going to be b over a, b over 2 is b over 2a, and b over 2a squared is b squared over 4a squared. So x plus b over 2a all squared, take away b squared over 4a squared. Now let's just solve this stage by stage. So if I add take away c on both sides, I get a brackets x plus b over 2a all squared minus b squared over 4a squared is minus c. Then I get divide by a on both sides, x plus b over 2a all squared minus b squared over 4a squared equals minus c over a. Add b squared over 4a squared, and I get excuse me for snuffling all the way through this one. Right, what else do we do? I'll simplify the brackets on this side before I do anything else. That will make life easier in a minute. So I want a common denominator of 4a squared. So if I times c by 4a plus b squared, and we've got a common denominator of 4a squared there. Oh, 4a squared, not to the power of 4. And then you can perhaps see this is sort of coming down to something we're familiar with. Square root both sides, well, x plus b over 2a. And what we get is plus or minus the square root. Now if I rewrite this numerator as b squared minus 4ac, instead of minus 4ca plus b squared, there we go, over 4a squared, and then take away this term, so minus b over 2a plus or minus, now square root of 4a squared is 2a, isn't it? And I can leave the plus or minus just on the top, b squared minus 4ac, and then the next line is the one that we are familiar with, and there's our quadratic formula. Okay, so we can get to the quadratic formula by completing the square on ax squared plus bx plus c. So any quadratic we can start with, we'll end up with that as our solution. And those of you that have seen some of this other stuff before, we obviously, as our solution, if we can have a solution, and this bit causes us problems, but I'm going to get onto that later in the chapter, so we won't deal with it now. So that's section 2.1 and 2.2 dealt with, and next video will be section 2.3.